This is the pencast for section 4.2, reduction of order. And you should make sure you read in the book about how reduction of order works. I will do an example here in the pencast, but the idea is pretty simple. So let's assume that I have two linearly independent solutions of a second order homogeneous ordinary differential equation. Then we know, based on what we proved in class, that y1 divided by y2 is not a constant. So it's some function that is not constant. And we can divide by y2 with no problems because we know y2 is not the zero function since this is a linearly independent set of solutions. So reduction of order says, okay, let's suppose I have y2, then I can find y1 by letting y1 be equal to this function u times y2, and we find u using the differential equation. So what we're going to see happens is that if I have a second order differential equation in y1, if I let y1 be u times my other solution y2, it's going to reduce to a first order differential equation in u, which I can solve using an integrating factor. So that's where we're headed. So let's take y double prime minus 25y equals 0, and we are told that one solution is e to the 5x. So this is a second order differential equation. Its fundamental set of solutions should have two linearly independent functions. So I'm going to be looking for y2 equaling u times u times y1 that solves this differential equation. So if y2 is some unknown function u times e to the 5x, then that means that y2 prime, using product rule, is u prime times e to the 5x plus 5u e to the 5x. And y double prime, y2 double prime, is u double prime e to the 5x plus 5u prime e to the 5x plus 5u prime e to the 5x plus 25u e to the 5x. Now, if I simplify just a little bit, I have u double prime e to the 5x plus 10u prime e to the 5x plus 25u e to the 5x. So that's what happens if I let y2 just be u times e to the 5x. In order to get a differential equation for u, I'm going to plug this all into my given differential equation, which is y2 double prime minus 25y2 equals 0. And if I do that, I get e to the 5x times the quantity u double prime plus 10u prime plus 25u minus 25 e to the 5x times u equals 0. And we see that two of those terms cancel, and what I'm left with is u double prime plus 10u prime equals 0. So notice here, this is a differential equation that is first order in u prime. So that u term dropped out, the term just containing u. And that should always happen in your reduction of order problems. If it does not happen, you made a typo somewhere. So what I'm going to do, the trick I'm going to do is I'm going to say, okay, let's let w be equal to u prime, and so this differential equation becomes w prime plus 10w equals 0. And that, let me play that for you in real time. So that I can solve using an integrating factor. So mu is e to the integral of 10x, mu is equal to e to the integral of 10 dx, which is e to the 10x. I multiply both sides of the differential equation by e to the 10x. And then I can write the left-hand side as the integral of a derivative of w times e to the 10x, and if I integrate the right-hand side, I get some constant. So w is equal to some constant divided by e to the 10x. Now, remember, w is equal to u prime, so that means u prime is some constant times e to the minus 10x. And if I integrate that, I get some other constant, which I'm still going to call c because that's how math professors roll. It's some other constant c times e to the minus 10x plus some arbitrary constant of integration d. Then y2, which remember was u times y1, is c e to the negative 10x times e to the 5x plus d times e to the 5x. So it equals c times e to the minus 5x plus d e to the 5x. But remember here, I'm looking for a solution that will be linearly independent with e to the 5x. And so I'm looking for something that doesn't have e to the 5x anywhere in it, because that's just additional information. So I make a choice, let c1 equal 1 and d equal 0, and what I'm left with is that y2, my second solution, is e to the minus 5x. And you might just go ahead and check that indeed e to the minus 5x solves the differential equation y double prime minus 25y equals 0. So since I have a fundamental set of solutions, my general solution to the differential equation is c1 e to the 5x plus c2 e to the minus 5x. These reduction of order problems can be a little bit tedious because there's a lot of steps, but make sure you do several practice problems before you come to class to try to get the hang of the procedure, because the procedure is going to be the same every time.